Hello everyone, so as promised an overview of the solution to assignment 4. A cooker has two hot plates controlled by two controls. Each control is on or off, and in order to prevent overheating it is not permitted for both hot plates to be on at the same time. That's the background. And the stage 1 was to specify the local state for a single hot plate and to provide an introduction rule. Well, in this particular case we have a type called control, and that type has two values which are on and off. We have a single observation called setting, which will be of type control and therefore have a value which is on or off. And really that's all we need in this particular case. We need to be able to observe whether the hot plate is on or off. It has a setting and that is either on or off. For the local state, for the single hot plate, there's no constraint on that at all. As for the introduction rule, as with all introduction rules for states, the conclusion will have this form, that some particular state S belongs to the state space in question, in this case hot plate. The premises on this rule will be given in terms of the declarations, and here is one, and in terms of the predicates, of which we have none at all in this example. But as you can see, this is an axiom, not a rule. It just has a conclusion here, but no premises. And the reason for this, as you probably know by now, is because in order for that highlighted proposition to be well typed, the observations in S must agree with the type specified in hot plate. And we can see that a premise of the form setting has to have the type control, which simply repeat that. So we don't need any extra premises here. So there we are, that's the first stage. Now, next stage is to specify an operation, a local operation, which would turn the hot plate fully on. That's all we were told, just specify an operation to turn the hot plate fully on and to provide an introduction rule. Okay, so first of all, the declaration is delta hot plate. That's to say, and as you know, it's shorthand for hot plate and conjoined with hot plate prime. So there are two declarations here. One is setting, which is the value before the operation, and setting prime, the value of the observation after the operation has taken place. And there is a constraint in this case, and it's down here, and it says simply that afterwards, in other words, setting prime value will be on. One could, I suppose, argue that you can't turn on a hot plate that's already turned on, so you might have thought it worth including another proposition in here saying setting equals off. In other words, before the operation, it's off. Actually, the language that was used to describe the operation, which is just here, didn't say that, so I've left it out, but one might include that. As for the introduction rule, let's just wait a moment. The conclusion, as always, for an operation will always look like this. Partitioning the state into two parts, S0 and S1, or S1 prime we should say perhaps. S0 being everything concerned with the before state, and S1 prime everything concerned with the after state. And the star just simply means joining the two bindings together to form a single one, and we want that of course to be an element of the operation on. So what kind of conditions do we have? Well, once again, the declarations of the observations are in a type called control, so we don't need any premises for them. We only need a premise for the predicate part, which said that setting prime had to be on. In other words, S1 prime dot setting prime is equal to on. And if S1 prime dot setting prime is equal to 1, then S1 dot setting is equal to 1. So we just have a single premise that looks like that. No problem. Good. Okay. Stage 3 was to specify the cooker state, which is going to be the global state, and to provide introduction rules for that. Now, in the cooker, there are two hot plates. So there are two observations. We've called them here set 0 and set 1, and they've also got type control. Okay, so that's given by that declaration there. Two observations, one for one hot plate, one for the other. But there is a condition here. In the case of the cooker, to prevent overheating, you can't have both hot plates on at the same time. So we have a condition here that says that setting 0 is off or set 1 is off. That's our condition. Right, then we have our introduction rule. Now what's happened here is that it's split up into 2 introduction rules, which is quite unusual, but it's not impossible. Essentially, we're going to have that as the conclusion, as we always would. On the top of that rule, we're going to have s.set0 equals off, or s.set1 equals off. So the single premise would be a disjunction. Now, as you very well know, you can argue backwards from a disjunction using the introduction rule, and you can do that in 2 different ways. And that's really what I've done here. I've just argued backwards from that disjunction in both different ways, and it's split up into 2 rules. One of them in which S0 is off, and one of them in which S1 is off, set 1 is off. So there we are. Right, so now we have the local state, which is the hot plate. We have the operation to turn the single hot plate on, and now we have a new state space, which is the cooker. And what we are asked to do is to specify now a linking schema connecting the single hot plate to the cooker state, and the schema needs to take an input that tells us which of the 2 hot plates should be turned on. And on the basis of this, the schema should link the local state change to the correct part of the global state change, and we need to specify introduction rules for this too. Well, again, it's quite straightforward. The linking schema will always involve a change in the state of the local state and a change in the state of the global state. So we have delta hot plate, we have delta cooker as well. If you think about it, the first of those is hot plate and hot plate prime, the second of them is cooker and cooker prime. So those 2 declarations provide us with a number of observations. We have setting and setting prime, we have set 0 and set 1, and we have set 0 prime and we have set 1 prime. So there's quite a few observations there. 1, 2, 3, 4, 5, 6. And then we also have an input which tells us which of the 2 plates it is involved. And plate is a new type, and plate has the value 1 or 2, which tells us which of the 2 plates we should have. The condition then for the linking scheme is a disjunction that depends upon the input. So in one case, it's that Z query, the input is 1, that hot plate, and in the other case, it's that Z query is 2, the other hot plate. Now, let's see. When we're talking about hot plate number 1, then the before value of the cooker, set 0, must be the same as the before value of the hot plate setting. And similarly, the after value of the cooker, set 0, must be setting prime. And the other hot plate chain doesn't change at all. That's easy to overlook, that last bit. On the other hand, very similar, when we're talking about the other hot plate, when Z query is 2, then it's set 1 that has to take the value of the hot plate before and the hot plate afterwards, and it's the other hot plate, set 0, that doesn't change in this particular case. So once again, we're going to get a disjunction in the predicate. It's going to lead to 2 introduction rules. And here is one. The other one's going to be on the next page. We'll see that in a moment. You can see that it's a much more complicated state. So, conclusion, as per usual, says that the before state and the after state will live in this linking schema under certain circumstances. First of all, that the before state is a member of the cooker and is a member of the hot plate as well, and the after state is a member of the cooker and the after state is a member of the hot plate as well. Now, just to remind you what this really means is S0 and S1 here are going to be states with quite a few observations in it. For example, S0 is going to be a state which has in its setting and set 0 and set 1, whereas S1 S1 prime, it's S1 here, but S1 prime is going to have setting prime in it. It's going to have set 0 prime and set 1 prime. Okay, so when we say that S0 is an element of cooker, all we mean is that the value of the set 0 observation lives in the right place. And when we say that S0 is an element of hot plate, all we're saying is that the setting observation in S0 belongs to the hot plate. Okay, so this really takes care of those 4 rules there. Then we're now dealing really with this bit of the proposition just here, which is a series of conjunctions. So we have 1, 2, 3, 4 conjunctions, and what we've got here are 1, 2, 3, 4 premises. I've stacked them one on top of the other rather than laying them out side by side, just simply because they won't fit on the page side by side. And as you can see, they follow exactly what you'd expect. First of all, Z query in the initial state must be 1. Set 0 in the initial state must be the same as setting in the initial state. Set 0 in the final state, that is set 0 prime, must be the same as setting in the final state, that's setting prime. And finally, the other hot plate doesn't change. So the value of set 1 in the before and the after states remains the same. So that gives us one of the 2 introduction rules. Let's move on to the other. Here is the other one here. Again, the conclusion, exactly the same. And what we have here is the premises are very, very similar to what we've just seen. I should say that the first 4, of course, are identical, and these are very similar. The first, of course, now Z query is 2 rather than 1, and then what we're seeing is that it's the other one that doesn't change, and here we have the coordination between the local and the final states. Okay, so now we get to the point where we've got to not just link the 2 states together, not just to link the cooker and the hot plate, but now we've got to connect that with the operation to turn the hot plate on, so that we can promote turning a single hot plate on to the condition where we're going to ensure that the cooker, we can turn that on. This bit, really, there's no excuse for getting wrong, because it always has this form. To promote the local operation, which is here, to the global operation, which is here, we can join it with the linking schema and hide away the changes to the local state, and then we simplify the versions of the introduction rules, which come to this. One thing to notice here very carefully is that the on operation contains a constraint that makes sure that the other hot plate is off, and that is recorded in the premise in this particular case. So here we have it there. The other one is off, and in this case it's the other one which is off, which is just there. Okay, so jolly good. That concludes our survey of the answer to assignment 4. Be marked soon. I hope you did well. Bye for now. Enjoy the exam, and keep working, keep revising. All the best.